Okay, for this problem, the acceleration of the puck can be determined by using a force that will be determined by plugging the value of acceleration into Newton's second law of motion. Newton's third law of motion is given as the following: v squared equals v0 2 plus 2 times acceleration, so x minus x0, and v squared can also be derived as v02 plus 2/8d. V of 0 being the initial speed, v final speed, acceleration for a, and d is distance traveled. So basically, with this problem we are given the initial speed, so we'll say here given v of 0 is 50 meters per second. Final velocity, or correction, final speed is 35 meters a second. The mass of the puck is equal to 0.11 kilograms. And for us to derive our distance, the distance is equal to x minus x initial, which is equal to 35 meters. So the next step we want to do is we want to isolate the acceleration from the equation. So to do that, we are going to derive that acceleration equals v squared minus v initial squared divided by 2 times the distance. And by substituting the values in the above equation, we can get the acceleration as followed. This acceleration equals, and by plugging in our numbers from the given. So we have acceleration equals 35 meters per second squared minus our 50 meters per second squared divided by 2 times 35 meters. And when we calculate that up, let's use a calculator here, we get a negative 118.21 meters per second squared. And the negative sign indicates that it's a decrease in acceleration. So from Newton's second law of motion, and the expression for force is given by this formula, which is force equals mass times acceleration. And by substituting the values from the given above, we can compute that force equals 0.011 kilograms times our derived acceleration of negative 18.21 meters per second squared. And when we actually compute that, we get a negative 2 newtons. So the horizontal force of the puck is 2 newtons. The negative side indicates the negative force. And that is our answer.